I'm Tim Ventura, and today we're joined by Dr. Seth Shostak, the senior astronomer for the SETI Institute. Today we're talking about his organization's mission to explore, understand, and explain the origin, nature, and prevalence of life in the universe. Seth has a PhD in astronomy from Caltech and a BA in physics from Princeton University. He's been awarded the Carl Sagan Award for the Popularization of Science and the Klumpke Roberts Award for Astronomy Popularization. He hosts SETI's weekly radio show and podcast, Big Picture Science, has played himself numerous times in TV and internet film dramas, and has acted in several science fiction films. Seth has also co-authored a college textbook on astrobiology, written 3 trade books on SETI, and published over 400 popular articles on science, including many, many other amazing accomplishments. Seth, welcome back, sir. It has been over a year since we talked.
It's hard to imagine, Jim, because honestly, it doesn't seem like a year. It seems like maybe because I was in a trance for most of that year. Who knows?
Well, so on that note, this has been a tremendous year. What are some of the things that you have been up to? Because there is so much happening with SETI right now.
Well, there is. I'm not personally involved in too many of these projects, but there are some projects going on that certainly excite me. And in particular, this project that's it's really, the result of initiatives over at the University of California in Berkeley, but it is to use the Very Large Array. And I think many of the people who are tuning into this discussion here will know about the Very Large Array in New Mexico. 27 antennas, I believe, sprawled across the New Mexico desert there. And you can use them, as they are doing, in a kind of piggyback mode where you don't have control of the telescopes, but you can, sort of filter whatever it is that they're picking up to look for narrowband signals, the kind of things that are of interest to SETI. So that's a very interesting experiment, I think, because it has the potential to look at a lot of the sky and see if they can pick up any signals that would tell us ET is out there.
Well, so you've touched on actually an interesting point. There are 2 SETIs, right? There is the SETI Institute, which is your organization, which is, I believe, the one that Frank Drake helped found. It goes way, way back when Carl Sagan was involved with that. There's also Berkeley SETI out in California, which you were just talking about. And then, as I understand things, the search for extraterrestrial intelligence is something that many, many other scientific organizations have at least dabbled with over time, right?
Well, that's true. I'm not sure I would say many. Maybe only one many is enough. Many might be too many. But, it is true that anybody with a radio telescope eventually will find that they have a couple of hours free, in the sense that they have, some scheduled time on that instrument, and the whatever objects it is that they are, studying may not be available for a couple of hours. I had that when I would study galaxies with radio telescopes in West Virginia. And there would always be a couple of hours every day where, none of those objects was accessible. And then I would just point the telescope at nearby star systems, hoping to pick up a signal that would tell us that there's somebody out there at least as clever as the residents of New Jersey.
Well, it inspires the imagination. That's one of the things that just grabs me with it, It's one of those things you look up at the night sky. I don't think anybody can help but wonder, are we alone? And if we're not, are they trying to reach us the same way that we've tried to reach them? It's so inspiring.
Yeah, I think that's a good way of looking at it. I mean, the first part of your assumption there is that there must be somebody out there. I think that you can argue that fairly convincingly by saying that if not, then you have to ask, what's so special about us, about our situation, right? Are there no other planets out there? Plenty of planets out there. Are there no other planets out there that could, host life? Well, there are plenty of those too, as far as we know. So it seems only reasonable that there are plenty of aliens. And, the question is, well, could we ever prove that? Maybe they're looking for us. If they're far away, they're not going to find us. If they're more than, say, 70 light years off, Earth will be quiet, as it were. So while there were, in fact, plenty of humans 70 years ago, they would be very hard to find. It would be hard to find the people that fought the American Civil War from a planet, light years away. They wouldn't have much clue that that was going on.
Well, and for people who look up and wonder, right, I think one of the things to keep in mind is Frank Drake had assumed there were about 10,000 broadcasting ET civilizations out there that we might be able to pick up. But that is a needle in a very, very large haystack, right? There are something like, if I remember right, 200 to 400 billion stars in the Milky Way galaxy alone. But then Frank had also assumed that there was a life expectancy for each of these ET civilizations. So when they are broadcasting may not be when we were around to receive them, right? So this haystack is giant.
Yeah, well, there is that. These considerations all figure into what's called the Drake equation. And indeed, you might be listening for signals in the right direction on the sky, in the direction of some nearby star systems that probably, may have had planets with intelligent life. But if that intelligent life hasn't arisen yet, or maybe they've self-destructed and gone away, there are all sorts of, other considerations here that might make this a difficult experiment, because, you want to find them, but you have to be listening when their signals reaching you, and there are reasons why that's not always going to be the case.
Well, so one of the reasons that I had reached out to you was I just saw a story about a new initiative by the SETI Institute, Berkeley SETI, and the International Center for Radio Astronomy Research. And I guess this collaborative project is going to be studying over 2,800 galaxies for signs of extraterrestrial supercivilizations. And this is a first, right? Because from what I understand, primarily it's been focused on our own galaxy in the past. So this is expanding that search considerably.
Yeah, it's not actually a first. I actually did this, not for 2,000 galaxies, for a far smaller number, like 25 years ago. So the idea is not so new. But on the other hand, it has never been done in a systematic way. The advantage of doing it is that if you point your antenna in the direction of some nearby galaxy, you're pointing it in the direction of hundreds of billions, with a B, star systems. So even if, galactic societies are fairly uncommon, if you're looking at that large a number of star systems, the chances are better that you might be looking in the direction of somebody who's sending a signal. The disadvantage, of course, is that galaxies tend to be a lot farther away than other star systems in our own galaxy. So the signal will be much weaker, and you might not pick up anything, not because there's nobody there, but because they're so far away you can't pick up their signal.
Well, it's weaker, and it's an older signal as well, right? Because
that probably doesn't. Yeah, but that doesn't matter much. It's an older signal. What do you care? I read books that were written hundreds, thousands of years ago, even, and I don't mind the fact that they're old. The fact that the signal was transmitted maybe hundreds of years ago or thousands of years ago, that's okay. It would still show that there was somebody out there able to build a radio transmitter, and that's the point of doing the experiment.
Okay. I just wanted to double check. Again, from what I've read, we are relatively latecomers in terms of, the age of the universe. And so I've always assumed that it's highly likely that civilizations, have come and gone many, many, many times over, right? Yeah. So those signals are out there floating around, right? As well as hopefully ruins, relics, robots.
Well, there could be all of that. In addition to signals, you're suggesting we could also look for artifacts, right? There are going to be societies out there that are much older than our own, just for the reason you stated. The universe has been around for, 13 billion years, or whatever the number is these days. And so, Homo sapiens has been around, well, only for a couple of 100,000 years, but the Earth and its life forms have been around for a few billion years, 4 billion. So most of the societies out there are going to be older than ours and presumably more advanced. So that might be a good thing, because it might make them easier to detect if they're more advanced than we are. They might be broadcasting powerful signals that we could pick up. But, that's speculative. All of it is speculative, in fact, until you pick up a signal.
Absolutely. Well, so I understand that this new project is using the Murchison Wide Field Array in Western Australia. and I'm not sure if that's something that's been done before. I wanted to ask, is that does that make it special, I guess, in any way? Is it just a larger array, or
yeah, it is a larger array.
That?
I'm not terribly familiar with that particular project, but the thing is that new telescopes, including even telescopes that aren't so new, like the Very Large Array in New Mexico, that's being used for SETI, but it's not being used for SETI as the principal observing project on the instrument. It's just that it's possible to look for signals that are produced by some sort of intelligence in the kind of data that is collected just for radio astronomical purposes. It's much easier to get funding for radio astronomy than for SETI. That's been true essentially forever. And that's because you're going to get some result when you do radio astronomy. And I used to do radio astronomy. I studied galaxies. You're going to get a result that you can write up and publish in a paper. But if you're doing a SETI experiment, the chances are pretty high that you're not going to find anything. And that doesn't make for a very interesting paper in a journal.
Yeah. Well, so in terms of other exciting projects that are going on, another one that we have talked about in the past is LaserSETI, right? And so you're looking basically for tight band laser signals from ET civilizations, or hopefully, like laser sail drive system signatures, anything that would use a laser that's hopefully coming our direction. So that would go in addition to traditional SETI, which is radio telescopes, right?
Yeah, it's just called optical SETI because indeed you're looking for light instead of radio waves. But indeed that has been done, for decades, that kind of thing. Again, the problem there is, well, where do you look, right? There may be plenty of lasers being wielded by extraterrestrials for whatever purposes. I mean, they might just be doing it to communicate with their home planet or whatever. But, to begin with, laser beams tend to be much more tightly focused than radio beams, right? That's just freshman physics, if you will. And consequently, they may be harder to find because the chances that you're in the beam of one of these communication lasers might not be very high. But the fact that there are communication lasers, nobody's proven that, but it certainly seems like a reasonable supposition.
Well, so there are a couple other things that for me are really exciting, and part of that is because of my IT background. But one of them is a collaboration that's underway between SETI and New Radio, which is an open source project that develops software for a wide variety of radio applications. And this is exciting because it seems like it may be able to potentially reduce cost and increase processing capabilities by eliminating hopefully some of the custom electronics that are used, right, in processing these signals. And just taking this open source also seems like it may open that up to different types of equipment, cost reductions, you name it, right?
Yeah, so far that hasn't played a particularly large role in, if you will, professional SETI being run at major observatories, because they already have software that allows them to look for signals, and even narrowband signals, and that's what you're trying to do. And that software has to be, unfortunately, sort of bespoke software, custom software, because, every radio telescope is different. You can say that that's not a good idea, but that's the way it's developed. And in fact, it might be a good idea, in my opinion, because that way you're not putting all your eggs in one basket. Only this kind of instrument is what we should build. Everybody builds whatever they think is most suitable for whatever they're planning to do, and that might be a better approach. But be that as it may, the software for analyzing those data is usually customized to a particular antenna. So the new software is great for amateurs doing SETI. SETI might be one of those things that amateurs can do very effectively because, yes, their antennas are smaller, which means they don't have the kind of sensitivity that a professional SETI experiment might have. But on the other hand, there are a lot of amateurs, and they could wield a lot of antennas, and that means they could be covering a far larger swath of the sky than you could do with a professional SETI search.
Well, so I'm going to jump around to my questions because that takes me to an idea that I had read about a while ago. And it's a little bit different than, I guess, it could go a couple different ways, right? But space-based wide array telescopes. And what you're saying is these smaller antennas don't have the sensitivity, but you can put a lot of them up over a very wide area, right? Now, in space-based applications, you could also get out of the atmosphere, so you could view a wider range of frequencies as well, right?
Well, actually, it's not such an issue. The atmosphere doesn't block much in the microwave part of the radio spectrum, and that's where almost all these experiments are done. So getting the antenna off the ground and into orbit just complicates your experiment, because now if something goes wrong, how are you going to fix it? The thing's not just a 1 hour drive away. So in fact, people think, oh well, we'll put these antennas in space and that'll improve the experiment. But in general, it doesn't. It's not a win. It doesn't buy you anything except a lot of problems.
Okay. And this comes out of, again, this was a slightly different paper I'd read, but it was a proposal to launch a microarray of very high velocity mini antennas, right, in a cluster towards another star system. And the idea was they wouldn't get there very fast, but on their way there, they could position themselves and pick up these wide array, I think it was optical images, but it could be radio as well, and so slightly different proposal, but still, when I read that, I thought, I wonder if you could do that for something like SETI.
Well, you could certainly try and send some hardware to another star system. You could do it. But even if you're sending it at, 7 miles a second, which is the speed of our fastest rockets, it still takes 70,000 years to get to the nearest other star. So you don't get significantly closer very quickly. So, you might as well stay on the ground where the food is better and use the antennas you have down here.
Let me ask about NASA's Roman telescope. And again, this is not directly related to SETI, but it is scheduled to launch in May 2027. Part of its role will include identifying candidate planets for future exploration by the Habitable Worlds Observatory, which is going up in the 2040s. So these are in the infrared, optical, and UV band, but I'm wondering if they may help augment or inform the SETI program, which has been primarily focused on the radio band, right?
Yeah, well, it might still be focused on the radio band, but what these experiments could do is, they're looking for exoplanets. They're looking for planets around other stars. And if you find a bunch of planets, you'd want to know, well, are these the kind of planets that might be interesting for a SETI experiment? Or are they, Jupiter-sized worlds that probably aren't so interesting as homes for ET? But one assumes that these experiments are going to find, if you will, Earth-like worlds, or at least Earth-sized worlds. Sometimes you don't know whether they're Earth-like. But, that would increase the observation list for SETI experiments. You could say, look, in addition to looking for SETI signals at all the obvious places around, Proxima Centauri or whatever, you can go another 10 light years out into space, and here are these other planets. So, it's you're on a hunt, and if you have more territory to hunt through, that's probably a good thing.
Yeah, well, and I guess the inverse is also likely, right? Like, so if SETI detects a candidate signal, and I understand that, potential candidate signals are found from time to time, right? You could send that over and have these telescopes take a closer look at that star system. So you might be able to work that both ways.
You could. I haven't heard that done so much because, I think astronomers are kind of reluctant to tell somebody who's doing their own experiment, hey, look at these objects for our experiment, but you could do it. If it was very compelling evidence, if you found a signal that looked for all the world, so to speak, like a narrowband signal, the kind that a transmitter would make, I'm sure you could convince some astronomers to look at that star system in greater detail.
Okay. Well, do you think that advances in AI and computer technology will be able to significantly help us in the near future? I wanted to touch on that because AI is, again, the buzzword of the year, right? And I'm wondering if there may be ways to apply that to more effectively process signals, reduce costs, you name it, in terms of these candidates that come in from time to time, or finding stuff, being able to pull it out of the background noise.
Yeah, well, AI is the buzzword of the year. I use it a lot at dinners with strangers, I just say AI, and immediately people stop talking to me mostly. But you're right. It's a very appealing technology that can help SETI experiments, and it's already being used for some SETI experiments. So I think that shows that there's some utility there in helping to pick up signals that otherwise you might not notice. So yeah, it's a good thing. It's like more sensitive receivers, right? That will obviously help in a SETI search. So this is something that can help you find signals that otherwise might be missed.
Yeah. Well, and the reason I asked about that was, again, just the massive amount of data to sort through, right? And so, then it brings up all of these questions of like, what if these signals were already there? It's just that, we're just not seeing them, or we're not seeing them more, clearly enough because we're just not able to process enough of the night sky all at once.
Yeah. Well, that's always a consideration in these kinds of experiments where you're looking for a needle in a haystack, so you want to be able to go through the hay more quickly. And that's basically what you're doing with this kind of an approach.
Well, so part of SETI, I think, relates back to the evolution of species, right? I mean, they have to reach a point where they're able to communicate so that we can hear them. And so I guess there are two aspects of that. One of them is there may be thousands, potentially millions of times more planets with primitive life than we're able to potentially see with SETI because they just don't have radios. But then the other side of that, people have argued maybe there's something better than radios out there. Maybe there's something like there's a device called an Ansible from science fiction for FTL communication. Now, as far as we know, that's not possible in real life. But some people have said, well, maybe they have something like that. So I'd wondered about that. Is that something that you've given much thought to?
Well, not a heck of a lot because of this. To begin with, faster than light communication violates some fundamental aspects of physics, but forget that for the moment. You can always appeal to technology we don't have and say, look, we're doing this all wrong. What you need is this kind of a device or whatever. But that doesn't help you because if you don't have that technology, there's nothing you can do. You can talk about it at dinner, but you can't do an experiment unless you understand the physics behind whatever it is you're talking about. So, they might lead to interesting discussions with the guy sitting next to you on the plane, but they don't have practical consequences in terms of modifying the experiment. You do the experiment that your level of technology and your scientific knowledge allows you to do, and that's the best you can do. I mean, it's like telling Chris Columbus, forget these, sail-powered craft, Chris. Just hang out for a while, and pretty soon you'll have steam-powered craft that'll cross the Atlantic much more quickly than you can do it, and it'll be a lot more comfortable too. Yeah, you could tell him that, but that, doesn't help him, and it's actually not necessary for what he's trying to do.
Well, the other part of that too is even if there is some, technology X out there, right, that does something that we can't currently detect, radio and hopefully tight band laser communications are something that civilizations are likely to evolve through, right? So, I mean, radio comes out of really basic electromagnetic understanding, and these are all things that you would assume that any advanced species would develop and then probably rely on just because it's an easy stepping stone. Maybe it's the final step, or maybe there is something after that, but that seems like a really something that would be very ubiquitous, right? So that makes it an extra great way to look for any civilizations that are out there.
Yeah, no, I agree. I mean, there are many, many ways to send bits of information from point A to point B, and using radio. And when you say radio, you mean just electromagnetic radiation. So it could be essentially, you could use a TV transmitter or whatever to do it, but that's all radio. But it does travel at the speed of light. It's very inexpensive to produce those signals. And, the technology to pick up those signals is so well advanced on this planet that you could pick up our TV stations, at quite some distance into space. And so, if they could do that, might be able to pick up their signals. So just looking at it from the standpoint of, well, what does physics say? It says that, this is a good way to go if you're looking for information being sent from one part of the universe to another.
Yeah. Well, in terms of sending at longer distances, and again, I'm thinking about this 2,800 distant galaxies, is there a different kind of power requirement to be able to detect those? I mean, I'm assuming it's more difficult because they're so much further away.
Yeah, no, that's exactly right. I mean, even the nearest galaxies are at least 10 times farther than the other stars in our own galaxy. So that means a factor of 100 in reduced, signal strength when you try and pick them up. And if you're talking about galaxies that are farther away, then, this becomes a real issue. Unless the aliens are either using, humongous transmitters for whatever reasons, hard to understand why they'd spend all that money, but there might be, or they are aiming their signals directly at you so that they don't need very much power to produce a detectable signal here on Earth. That would make the job easier, but on the other hand, then you have to ask, well, why would they be targeting Earth with their transmissions? Unless they're very nearby and they picked up some of our transmissions and they know we're here. They're not going to construct massive transmitting setups to send signals to, bacteria or trilobites or anything like that. So unless they already know that we're here, I suspect that they don't spend a whole lot of time beaming signals our way.
Yeah. Yeah. Well, and again, this just goes back to the tremendous amount of work that everyone involved in SETI is doing, and that is why, again, it's such an absolute honor to be able to interview you on this, because you guys are working so diligently on such a massive project. I mean, it's not like just pointing a radio up to the sky to listen for a signal. It's complex. There are lots and lots and lots of data. It is like a needle in a haystack, just multiplied by orders of magnitude, right? So
yeah. No, it's not a terribly easy experiment. But on the other hand, the idea of what we're doing is not so difficult. That's something anybody can understand. You're trying to eavesdrop on signals that the aliens might be broadcasting for whatever reason, and thereby proving that there's somebody out there. So that's pretty straightforward. The equipment to do it is, as you say, not necessarily so straightforward, but on the other hand, that's the engineering part of the problem, and the engineering of any problem is usually more difficult than the fundamental idea.
Absolutely. Well, and that fundamental idea is so inspiring. So Carl Sagan, wrote Contact, which was made into the movie adaptation with Jodie Foster. And I have probably seen that 20 or 30 times since it came out in the late 90s. It's just one of the most amazing, imaginative movies,
Yeah.
So.
Yeah. I have to say, I almost took a job with Carl Sagan at one point. I didn't do it. But I did later on become, I was a consultant, actually, for the movie Contact. So I had something to do with it. They would call up, the producers of the film would call up once a week or twice a week, and they would ask, questions, mostly of a technical nature, or else they would want to know, well, what does it look like, this piece of equipment or stuff like that. They were trying to get the science right, whatever that means. But I don't think the audience actually cared. The audience for science fiction films, at least in my estimation, doesn't really care whether the science is right. What they want to know is this an interesting movie? In other words, does it have an interesting storyline? Does it have interesting characters? That kind of thing. And that usually has very little to do with the scientific accuracy of the story.
Yeah. Well, and one of the takeaways for me was, when everyone else is going about their day-to-day lives, Ellie, I think the protagonist, was out there listening. Right? She had her laptop. She was out there. I remember her sitting on her car hood at one point out in front of the telescope array, just listening, just looking for signals, And I think that's important to remind people of, is that while they're going about their daily lives, right, all the normal stuff that we do, SETI is listening. So that, again, is a tribute to what you guys are doing.
Yeah. Well, it's also probably warmer in the desert to sit on the hood of your car.
Yeah. Yeah. Well, Seth, let me thank you so much for your time today. It is absolutely wonderful to be able to touch base with you again after a year. I would love to do more podcasts with you in the future if you're open to it when you have the time. Let me close by asking what is coming up in the next few months for yourself and the SETI project?
Well, the SETI project will just go on, whether, I'm dead or alive, really. But for me personally, I guess what's coming up and what has actually typified my daily activities for the past month or two is travel. I travel and I give talks, that kind of thing, which I enjoy doing, not so much giving the talk particularly, although I do enjoy that, but it's meeting the people in the audience and talking to them one-on-one or across the table at dinner and that kind of thing. So I'll be doing that, going to the East Coast and giving some talks there.
Well, thank you again so much for your time today, sir.
My pleasure, Tim. Hang in there.